Good evening, Guy-Vincent.
Good evening, Marcel.
So we're here for the assignment number 3.
That's right. So the assignment was published a couple of days ago.
Yes.
And we just want to give you a little overview of what you need to do this time for this new version of the Light Out game.
Shall we go to the description of this assignment?
So let's do that, yes. So now we have only 2 questions really this time. And so propose that we look at those questions in order. We start with a little bit of an evolution on what we had before for the game. So before we had developed a solution that was based on the stack and that could find all the solution for an all-off board. And so if I give this little example here, so this is an example of 3x3 light out game, and if you were to have run that on the previous assignment, your code would have found just one solution, which is that in order to complete that board you have to click on the corner here and also on the center. Okay. So your code is able to find the solution assuming that you start from that game here, that board, which is completely off. But if you try to use that in a real setting, the user is going to interact with the board. So the user might click here and then click here and then click here. And then your solution is just not working because the user has not followed the optimal solution that you have provided that goes from completely off to completely on.
So the idea here is that the user has played for a little while, and then this user says, no, I need a hint. And this is, so your starting point is where the user is currently at. That's the starting point, and you want to know, is there a way that I will click on these tiles and get a board that's all lighted?
That's right. And so you cannot really just use what you have done before. Again, if I were to click on these 5 points here, I will definitely not finish the game. In fact, to finish this game here, I have to click here, and then here, and then here, and then here. Okay, so that's really the gist of the question here. So now we just need to update our code so that instead of working from an unspecified, completely off board, we want to be able to specify how do you solve this board given that this is its current positions. So in order to do that, we will provide a description of the board that you need to solve. So it's the state of the game. It has nothing to do with the UI. So it's not, you are not providing the UI here. What you are providing is some sort of description of the current state. So here it would be completely off, but again, if I do that again, it would say that, okay, you need to resolve that game given that these 1, 2, these 2, 1, 2, 2, and 2, 3 are on, yes, and all the other one are off.
So it's not that they are clicked, is they're lighted or not.
That's right.
And so what we're going to call the game model in a moment is what is behind this UI. It's not a UI, it's just an object that represents the current state.
That's right, exactly. And we are going to call it here the game model, and you will see as soon as you reach question 2 why we use that name. Okay. So the game model is just that, the current state of the game, the board, and that's the constraint on which your solver should work to find the solution.
Correct.
So it has a few methods here. You create it with a given width and height. Initially it's completely off. You are going to specify which of the elements in the board are on or off by basically calling the set method. So set that the column I and row J is on or off. And so you can completely specify the board this way easily by just setting the ones that are on and off. And then you will be able to query back. So it's sort of a getter for these values here. Is on will tell you whether or not the row I and the column J is on or off. Be careful that the meaning of I and J is reversed between is on and set, and that's because we are sort of connecting the logic of the question of assignment 1 with the logic of the UI layer. So you have to make sure that you are using the right meaning every time.
Which is why we're underlining a lot of
yeah,
things in there.
Trying to make it as clear as possible.
Okay, so
that's the game model. And then the rest is basically looking at the existing code that we had before that was working with an unspecified assumed model, but it had a model which was all off. Now we want to specify it. We want to say, well, this is the model.
Yeah,
and
with the previous assignment, there was no need for a model to specify that the tiles were not illuminated. They were all off.
They were all off. It was always the same.
So here, game model changes that. It's providing the information about which cell is illuminated or not.
Right. So what we have done here is we have identified those methods that are going to be impacted by that. And for all these methods, you need to provide a new version that will receive a model or a reference to a model as a parameter. Now, so that's still possible and finished for solution, and that is going to be, of course, solved for lights out. What we ask you to do is to try to do that in a way that does not destroy what you had done before. So you already have a solve method that does not get any parameter. You already have a still possible that has just one parameter. We want you to keep that. So all the tests that were run on the assignment 1 should still pass on the assignment 2. So your challenge here is to have your code, to evolve your code a little bit so that now there is a second version of all these methods that does receive a game model. And the added challenges that we are trying to set here is that we don't want you to basically copy over the code to another method. So let's try to keep the amount of code duplication to a minimum.
Okay.
So you may have to switch things around to manage that. And the last thing that we do in this question is, so when you have a solution, the solution requires the user to click a certain number of times. And the different solution, when you have more than one solution for a board, the different solution may require different amount of clicks, a different number of clicks. And so we want to add this idea of the size of the solution, which is how many times you are supposed to click on the board to execute that solution. And so get size will tell you that. And so we now have a new method here in lights out, which basically just return one of the solution instead of returning all of the solution, and the one it returns has to be the shortest. Now there may be more than one shortest solution, and you can return any one of those short solutions.
Sounds clear to me.
Okay, very good. Okay, so moving on, so there is a little bit about using your own implementation of a queue and a queue implementation. Okay, that's clear enough. We provided some testing code, so make sure that your code passes everything before you move on to question 2, which is really the UI.
Yes.
Okay, so the UI looks like that. It has several buttons, it has a checkbox, it will display the game, of course, and you can play with it. So here is, if I get this here, this is the UI with the default size, and as such it's just a UI. So I can play the game, and it will just give me everything that I need in order to play. And so it gives me some information like the number of steps and etc. Eventually, if I were able to solve that, I would solve it and it would tell me, yeah, you did it.
Yeah, so you can play in the unassisted mode and
I
complete the game and
that's right.
have a lot of fun.
I can really go crazy with that.
Okay.
So now I reset that, and so in order to do that, though, how are we going to implement even that part of the question? And that's where we are going to use the model view controller type of pattern. And we are going to have a different videos just about model view controller.
Yes.
So we're just going to go very quickly over that now.
In a nutshell, then, the model view controller is this idea that we should separate the concerns very well, that each part of the software should be responsible for one and one thing. So the model is what we just said. There's an object game model that represents which particular cell is illuminated or not. There is another component which is the view. The view is a reflection of the model. It consults the model, and for every possible cell, it's asking the model, should I put the orange light or the gray light in front in this view? And then the controller is there to be the brain. It's implementing the logic of the game. It knows about the logic. As Guy-Vincent was saying, we're going to have a separate video where we can explain all the benefits of this particular model.
Okay, so when we implement that in this particular case, so that's why we had this game model thing in the first question. Now this we need to make it a little bit more powerful to be able to work in our UI. So we start from the game model of question 1, and then we will add a few new methods, like for example the method click, which will transform the model based on the rule of the game. So if the column I, row J is tapped, then it will switch the state of that position from off to on or from on to off, depending, and the neighborhood of that position will also be modified according to that logic. It provides some other information about the current state of the model, how many times you have interacted with the board, whether or not the game is currently finished. It has this ability to randomize the game. So if you start, let me show you here, perhaps. So I have this game, I can play with it. If I, reset. Okay, so I have this game and I can play with it. But if I want to start from a different board, not an all-off board, I can click on random here, and this will trigger a method in the model that is going to start from a random board, like that. And every time I click here, I get a different starting point.
But these are feasible.
That's right.
Solutions.
So, as maybe you recall from the description from assignment 2, it is possible to have a board that you cannot solve. And so here, the constraint is don't generate that. So you don't put your user in a position to try to solve something that cannot be solved. So when all of these games here that are being generated randomly are all solvable.
We only want happy customers.
That's right. So that's the part about the randomness. And then finally there is the last part, which is, okay, what if I don't know how to solve this thing and I want to just solve it?
I give up.
I give up. So what I can do is ask for a solution. Click here, and now the system is telling me, okay, well, if you were to click on these positions that are now displayed in a slightly different color, then you would solve the problem. And it is a solution, and on top of that, it is the shortest.
So this really connects the two parts of this assignment.
That's right.
So we're now providing the solution with a starting point, and we're asking it, where should I click in order to solve this particular board?
And so, okay, if I remove the solution, put it back, okay, start from a random board again. And one thing about that is, okay, if I follow the solution, it basically I'm clicking everywhere. But if I don't follow the solution, then the solution has to be modified accordingly. So it's always, as these checkboxes ticked here,
Okay.
the solution that is being displayed is always a good solution.
So it's like the GPS in my car. If I
Exactly.
change direction, it recalculates a new route.
That's right. That's right. We want a GPS type of approach here. Okay. So that's the UI. So as we said, so there is going to be a model in the background that does these kind of things. It can fetch. It can use question one to find a solution for its current board. One thing that we say here is that the model is not itself responsible to make sure that the solution it knows is the solution for the current board. So you will understand that better once you understand model view controller. But really, the model just stores the things, and it doesn't want to do the computation on its own. So it will find a solution for its current state every time the set solution method is called. And you can at any moment ask whether the solution it has uses the row I and column J or not. But if you have not refreshed the solution, then it may return something that is inaccurate, because the board is displaying something, but you have not asked the model to refresh its solution, so it has a stale solution and it will just return stale information. So that's the model. The controller is the brain here. It knows what to do, it knows about the views, it knows about the model, and it is the one in charge of deciding what to do when the user interacts with the game.
So it would, for instance, if the game is finished, display a pop-up message. It knows all these things.
That's right. And so finally the view is what we have seen here. And let me remove the solution here. So that would be the view, that graphical user interface that at any moment reflects what the model holds as a state. So it's just showing what the model right now says the board should be. It doesn't know why it's showing that, but it is showing it.
Yeah, and it's really not memorizing anything. It's just every time it's asked to update, it reads line by line the information in the model, and it copies this information to the view.
That's right.
Okay.
So I think that's yes. And to build this UI, we have provided some icons for that. So a class called .button, which we have seen in a lab.
Yes.
And so if you use that, you should be able to get something similar to what we have here.
And similarly to the previous assignments, we're providing a starting point. So if you go to the files section and you click on the archive there, you have a number of files that are provided for you, and there are the icons as well.
That's right. It's right there. There is also the Java doc that has been generated that you can use. One thing that we should probably specify is that this is a continuation of assignment 1. So you can start from your own implementation of assignment 1. That would be fantastic. If for some reason you would rather not do that, you can also start from the solution that we have provided.
Sounds good.
And yeah, so I think that's it.
Yes. So let's get started.
Okay. Good luck.
Bye.